So now that you have some basic understanding of a convolution in image processing, the next question obviously that comes to your mind is, why study image convolution at all? I mean, there is a lot of math involved. What's the point in doing that? So I'm trying to build the motivation by giving some examples. To see this in action, let's head over to a website called Setosa. That's one of the websites that I really like. So this is that website. Okay, let me go over there again. I hope you can see that. Let me zoom in a little bit. Let me zoom down. So here you see, and again the same image, the image of Pittsburgh skyline. This is the original image, and then let's try applying and some effect. Okay, so again what it's going to do is, this is the matrix that we saw earlier. It's going to convolve this matrix over the original image matrix, and the effect, final effect, you can see visually, because human beings understand visually a lot better. So that's why I am showing the visual effect after applying this kernel. It's called kernel, right? The small matrix that you convolve over the image matrix is called a kernel. So let's apply a filter called blur. So remember, this is the original image, and when you convolve with blur, and the final output would look like this. As you can see, the image has been blurred, right? So blurring, basically, by what it means is, it has reduced the difference between the adjacent pixels, and you see a much more smoother and much more blurred image because of that. And all it did was, it took this 3 by 3 matrix with these values, convolved, basically multiplied them with the original intensities in the pixel, and then took a sum, and then it slided over this kernel to the from left to right and from top to bottom, and repeated the process for all other pixel values in the original image. And this is the final effect. Let's see some other kernel. So let's talk about bottom Sobel. So bottom Sobel is basically used to emphasize the value in the bottom part of the image and de-emphasizes the value in the top part of the image. So as you can see, this is the kernel that is used for bottom Sobel effect. So as you can see here, the top values are negative values, which means we are going to decrease the intensities in the top rows, right? And the bottom values are the positive values. That means we are going to increase the intensity in the positive value. And the middle row is 0, 0, which has no effect. So the net effect on the entire image is, the bottom part of the image is highlighted more as compared to the top part, right? So this is the bottom Sobel effect. Let's take example of a next kernel. Then this is the emboss kernel. The emboss kernel, basically it gives the effect of a depth. Basically you can see the illusion of a depth, right? You feel the bridge, like it's like a more like a 3D image now. It has emphasized the difference of like white pixel, it has made more white, and black pixel it has more gray, and because of that you see that it looks like the 3D image, right? It looks like if the bridge is almost front of the building in a 3D direction, and you can see a little bit of depth even in the buildings also. Again, to highlight, let's go back to the original image. This was the original image, and this was after applying the emboss effect, right? So the embossing effect basically highlights, it gives a perception of depth. Then let's look at the left Sobel. Similar to the bottom Sobel, the left part emphasizes the left part of the image and de-emphasizes everything else. And this is the matrix, this is the kernel for that. Similarly, you can see right Sobel, it emphasizes the right side of the image. Then top Sobel, you can see it emphasizes the top part of the image. Again, I am highlighting the top Sobel and the bottom Sobel. This was the bottom Sobel, where it was highlighting the bottom part of the image. Top Sobel, it's highlighting the top part of the image, right? That's the difference. Let's look at some more kernel outline. This is my favorite filter. again, as you can see, it is just applying this 3 by 3 kernel with a different value, and basically what it is doing is highlighting the large difference in the pixel values, right? uh, so what basically does is a pixel to the neighborhood uh, pixels with the close to the same intensity will appear in the new image, while one next to the neighbor pixel will strongly uh, appear white, right? That is what it's doing. Basically, the net effect is uh, if the difference between a white pixel and black pixel is large and they are in the neighborhood, it will emphasize that difference. And the net effect of that is basically outlines are basically highlighted more clearly, and the rest of the image stays as it is, right? By highlighting the difference in the neighborhood pixels. That's what it is doing, this particular effect. And this is again a fundamental in when you learn about convolutional neural networks. These are the very important, this is a very important effect in order to identify the objects in the image, which is called an outline effect, right? So well, we saw sharpen. So this image uh, is effect is used for making the image look more sharp, and it is doing by emphasizing the difference in adjacent pixel values, right? That's all it's doing. And again, this is the kernel that is used for that. So sharpen, outline. So outline amplifies the large difference between the pixel values, but sharpen just outline any difference in the neighborhood pixel values. That's the main difference. So as you can see, you saw the number of effects that can be created by using the kernel, and it's a convolution process. And you saw different examples like uh, emboss, which is used for creating the perception of depth. Then you saw left Sobel, right Sobel, top Sobel, uh, bottom Sobel, which is used for highlighting the left, bottom, top, and right section of the image. You also saw an outline where we are amplifying the large differences in the pixel values so that outline is clear. And then we saw also sharp, where you amplify any difference between the image values, and these are the different kernels. So as you change, you see the kernel values are changing and the impact of that on the picture. You can also play with this by modifying these values yourself, and you can see the impact like this. You can see the impact of that, right? So you can play with it. This is setosa.io website. You can go there and you can play with this in order to appreciate the impact of several image convolution operation on the image.